Okay, so we got translation on the S axis, and all that means is that we're changing variables back and forth to help us solve these differentials. So the first translation theorem states that if you see a function with e to some constant a times t multiplied by another function, we can translate it to that function like that Laplace transform to f of s minus a. So a couple things that you want to just keep in mind: the a there has to be the same. So what I mean by that is if you have like e to the 5t times t cubed, right? What you should do is just kind of like kick out that e to the 5t and making that s minus 5. So again, right, you see the 5 there. What that means is once I do this Laplace with t cubed, I could then translate it with the s minus 5, s2 s minus 5. So like if you know your rule for t cubed, you're doing 3 factorial and then add 1 to the exponent, so you have s to the 4th. And now I will replace the s with s minus 5. So I'm going to get 6 over s minus 5 to the 4th. Okay. Let me do another example of this before we get into the inverse. So here again, right, you have e raised to something, so e raised to negative 2t cosine 4t. So now we know cosine, so we do a similar thing. Let's do the transformation of cosine 4t, but afterwards we're going to replace it with the s with an s minus, actually s plus 2. So cosine we know is just going to be s over s squared plus whatever the constant coefficient, so 4 squared would give me 16. And now everywhere I see an s, I'm putting s plus 2. So I'll get s plus 2 over s plus 2 squared plus 16. Okay, so now we got the inverse, which is pretty similar. It's just like you're going backwards, trying to locate like a function in terms of s minus a. So here we'll have so it's basically just stating the same thing just backwards, right, with the inverse notation. So if we have, say, okay, so you could see that s minus 3 is in there, so we're going to have to use that, but the numerator is not what we want. But what we could do is partial fractions again. And this is with repeating, so if it repeats, I might have went over this earlier in the class, right? You got to think of, you know, if your common denominator is 4, you have 1/2 plus 1/4, right? So that's where that squared comes in, where this is going to be s minus 3 squared, like that, because you could see that's 2 squared when you're adding those fractions together, right? All right, so here I'm going to get 2 plus 5, so I'm only dealing with the numerator, a s minus 3, and plus b, right? You don't need it for that one. So a couple things you could see, right? A is going to be 2 because if you line up the coefficients, we would get a to equal 2, negative 3a plus b equals 5. So b has to be 11. And now we could do the Laplace inverse with a is 2, b is 11. All right. So this first one you should know, 2 just comes out and it's e to the 3t plus, you could kick out the 11, okay? And then if you remember, right, going backwards again, like really this portion, right, I'm gonna have that e to the 3t because of that inside, right? And then if you have to, you could go back to 1 over s squared, and we know the inverse of that would be just t. So then you would have times t. And that would be it. Okay, let me do another example. A lot of these you'll have the partial fractions. So s over 2 plus 5/3, and then here you have s squared plus 4s plus 6. So this one's a tricky one just in the sense like what do we use? And this really, the denominator doesn't really help us all that much. So when that happens, you know, you can't factor, you can't do anything. So maybe completing the square works. So when you complete the square, just focus on the first 2 terms and then take half of that coefficient of that second term and square it. Not 2, that would be 2 squared, so that's 4. Okay? And then whatever you add to the problem, so I'm adding 4 to the problem, I gotta subtract 4 to that problem as well. So now I'll have s plus 2 squared. So all I did there was just square this now. I mean, factor that. And then I'll have plus 2. And if you notice here, this looks similar in the sense that if it was like an s squared plus 2, right, that's either going to be a cosine of root 2t or a sine, right? Sine of root 2t, depending if you have an s or if you just have 2 or root 2, sorry, right? So that's where I'm going with that. So if you're just noticing that, that's why we want to do that there. Okay. The only problem here is when you're doing these problems, and if it's the inverse and you want to use that, because this is telling me that it's going to be e to the negative 2t. This s up here also has to be in that form of s plus 2 because you're using this e value, right? And you're going backwards. So let's do that here, right? So what I'm going to do is just change, like put 1/2 s plus 2. So all I did was just change the s to an s plus 2, and I said, well, what am I really adding to the problem? If I distribute that 1/2, I'm really just adding 1 to the problem. So I'm going to say, okay, plus the 5/3 minus 1. And that would give me, I would have my 1/2 s plus 2, and then this would give me 2/3. So I would have plus 2/3, and then I have the function with s plus 2. So I know everything needs that e to the negative 2t, right? So you know, I mean, could be easier, right? If you just want to kick out the e to the negative 2t to start, and then just do your inverse of, just now that you use that e to the negative 2t, you could get rid of the s plus 2 and just go back to it being just an s. And now we could use, you know, just break up the two fractions, right? So you have this, and there's your cosine, right? And then you have a 2/3 over s squared plus 2, which will be our sine, but we just have to do a little work there. So I'll have e to the negative 2t, and this is going to be times 1/2 cosine root 2t, right? And then plus 2/3 times, well, I want this to be, root 2 should be up here, right? So let's just do 1 over root 2, and then that, you know, if I do 1 over root 2 here, times root 2 here, right? Then I know I'm just multiplying by 1, and then that would give me the sine root 2t. Now some of you might leave this s plus 2 there the whole time if you get it, and you'll wind up with a similar answer, and I'm just going to simplify by distributing through. And this would wind up being root 2 over 3 e to the negative 2t sine root 2t. Perfect. All right, and then you would get that. Okay, so with all this, now you go into the initial value problems. So we'll have one, you know, you'll have a similar problem, right? And there you have that weird setup, right? Where you have the t squared, but there's your e to the 3t, so then we could use that inverse, right, and transformation on the s-axis. So let's do our rules for each. Okay, so here, just remember when you're doing this, it's going to be s squared. Squared usually matches the the inverse. Hold on 1 second. Okay, so s squared, that usually matches the derivative. And then, right, the easiest way is just to go make sure you end with the last derivative prior to that. So it's going to be like minus y, y prime of 0. So I kind of screwed that up in the explanation, but what I meant to say was that is our first derivative, this was our second. So I mean, you can see it's kind of like it's in order of what you have to do or remember, or just have it in front of you, you know, because who knows what you guys are doing or use it. Okay, so here you'll have 6 times. Now this one is s y, capital Y of s, and then minus the initial value, and then plus, this one is the easiest one, y of s, and then that's going to equal, and that's here's where that a comes in, and I know it's squared, right? So if it's squared, I'm doing 2 factorial over, now I'm going to plug in that s minus 3, and then that is going to be cubed because you're adding 1 to the exponent. Now simplify this whole thing, so s squared minus 6s plus 9, they are all in front, so those are all the like terms for the capital Y of s, minus 2s, now I'm just plugging in, minus 17, distribute that 6, I get plus 12, and there we have equal to 2 minus cubed. Alright, so let's rewrite this as s minus 3 squared, right? So you have s minus 3 squared, y of s, let's bring everything to the other side. So you got 2 over s minus 3 squared plus 2s plus 5. If you divide, so this becomes to the 5th, and here we have just squared with those two. All right, cool. So this first one I'm going to leave, but this one was the previous examples, right, all the way up. If you scroll all the way up, you'll see it. And then I did partial fractions, and I got 2 over s minus 3, and then plus 11 over s minus 3 squared on my previous examples. And now we use that, you know, your properties that we have. So because this is to the 5th power, right, it should have a 4 factorial up there. So what I'm going to do is write it this way. So y of t is going to be 2 over 4 factorial, right? So if I'm doing like a 1 over 4 factorial there, then I would know it's going to be e to the 3t because of the inside portion. And it's to the 5th, right? So you go back 1, so you get t to the 4th. Second term is very easy. It's just 2e to the 3t. And the last one we already did, right? So we got 11t e to the 3t. If you just want to clean it up a bit, you could say that this is 1/12, right? And then e to the 3t, t to the 4th, plus 2e to the 3t. T e to the 3t. And there's your answer. Okay, so that's the first part of 7.3. Second part to come shortly.